Hello everyone. Welcome to Lesson 5 of the Crowpanel ESP ePaper HMI display tutorial series. In this lesson, I will lead everyone to use Wi-Fi to display images on the screen. The final effect that this tutorial aims to achieve is like the conference desktop shown in the picture. Use a laptop to transfer photo files through a Wi-Fi connection called ESP config, so that you can observe the refresh of pictures on the display screen, making it convenient for everyone to flexibly replace the pictures they want. The steps may seem complicated, but the operation is actually very simple. Next, I will take you to unravel the mystery. In this tutorial, there are 6 types of motherboards in this series mentioned in the previous lesson. Taking the 5.79 size as an example, we will introduce the use of related functions. The implementation steps of other sizes of motherboards are similar to the case steps in each lesson. You can refer to the video for operation. If you have any questions after careful study, please contact us. In this course, we will take the 5.79-inch ink screen motherboard as an example to explain in detail how to transfer images to the ESP ink screen through WiFi. The entire tutorial is divided into 2 main parts: preparation before the experiment and specific steps for WiFi image transfer. Part 1. Preparation before the experiment. Before starting, we need to ensure that you have prepared the materials and tools required for the following experiments. 5.79-inch ink screen. This is the core component of our experiment, used to display images transmitted through WiFi. USB-C serial cable, used to connect the ESP32 motherboard to your computer for program burning and debugging. We have provided a wealth of materials for everyone, which you can download through the link below. After downloading, open the ESP32S3 ink screen information folder, then open the conference table material folder, and finally open the conference table folder. Click 5.79 and you will see all the materials that can be used in this course. Before using these materials, you need to convert them to bin file format. This is because when ESP32 ink screens receive images through WiFi, they need to be transmitted in bin file format. If you want to use your own images, you need to ensure that the resolution, length, and width of the images are both multiples of 8. This is determined by the display characteristics of the ESP32 ink screen. After cropping the image, you can use our provided image 2LCD 2.9 cracked version software to generate C arrays and bin files. We have provided detailed instructions on how to use the image 2LCD 2.9 cracked version software in previous courses. If you need to review this section, you can refer to the steps in Lesson 4 to ensure that you can proficiently generate the required C arrays and bin files. Now that we have completed all the preparation work, we will proceed to the second part of the tutorial, transferring images to the ESP32 ink screen via Wi-Fi. Firstly, please open the information folder ESP32S3 ink screen information we provided. Then go to the 5.79 ESP32S3 directory. Select the sample code folder and open the 5.79 Wi-Fi refresh project. Open the INO file using Arduino IDE. You may notice that the code in this INO file is quite long. However, you only need to focus on a few key points, and the rest can be roughly understood by reading the comments. In the code, the depth size and name size variables are used to describe the size of the bin file of the image you generate. In our example, these variables are used to store pictures of departments and names, respectively. You can define the names of these variables according to your own needs, but please ensure that their sizes are consistent with the size of the bin file you generate. Next, please pay attention to the awk page function. The purpose of this function is to check whether the received file size matches the depth size after a successful file upload. If the sizes are consistent, name the file depth. Bin. If they are not consistent, check if they match name size, and if so, name them name bin. The file name will start with a / followed by the corresponding file name for saving. After determining the file name, Store the uploaded content in two arrays, dep formerly and name formerly. Then, call the EPD showPicture function to display these pictures at the specified position of the ink screen. During use, please pay attention to the limitation of image resolution to ensure that the image can be displayed correctly. If you need to review how to use the EPD showPicture function, you can refer to the second lesson in our series of courses. Next, let's focus on the UI table function. This EPD showPicture function is used to fix the display of the company name at the top of the screen so that you only need to replace the image content below. Among them, Image Conference 1 is stored in the app29 demo.h header file after I convert the picture into a C array. You can call it directly in the code for display. In the code, we also check if the /dep bin file has been stored. If the file exists, the program will directly call the display function, close the file after display, and set a flag to indicate that the dep file already exists. At this point, our code parsing comes to an end. During use, you only need to adjust the parameters in the EPD showPicture function and the bin file size defined at the beginning of the code according to your own needs. After the modification is completed, you need to configure the running environment. If you don't remember how to configure it, you can review the content of our first lesson. Next, compile and burn the code, waiting for successful burning. After successful burning, you can use your laptop to connect to a Wi-Fi network called ESP32 config. After successful connection, open a browser, access 192.168.4.1, and select the bin file you previously generated. Before sending, please confirm again whether the size of your bin file is consistent with the size defined in the code, as this is related to whether the image can be displayed correctly. After confirming the accuracy, click Send and you will be able to see the image represented by the bin file on the ink screen. By repeating the above steps, you can also display the name section on the screen to obtain a complete conference desktop nameplate. Through these steps, you can flexibly update the content on the ink screen, whether it is department information or name, which can be easily replaced and dynamically displayed. The size of the bin file generated by each image will change in different sizes due to the maximum resolution limit of the screen. For example, the bin file size required for a 4.2 size image is determined by the resolution of the image you want. Simply design the length and height of the image resolution to not exceed the maximum resolution of each size, and the length and width values should be multiples of 8. So in this lesson, you only need to modify the bin file size and image resolution. When using the Image2LCD software to generate bin files and C arrays, please note that the scanning mode for size 3.7 is set to vertical scanning mode. Next, we will show you the differences in bin file size and required image resolution for other sizes of images, as well as the final effect for your reference. The power consumption generated by our series of ink screen products is actually very low. After burning the code, we can observe the programmable power supply. When the output voltage is reached, if the display screen is observed to refresh when powered on, and after a while, the power consumption decreases from 0.5 U to 0 W, it indicates that the low power mode has been entered. We have observed that our series of ink screens will enter a low power state after working for a period of time. Now we stop the power supply for observation, and even after entering a low power state, our screen can still display. That's all for now. If this class has been helpful to you, we hope you can give us feedback and encouragement. Thank you for watching. See you in the next episode.